Okay, today's lesson is calculating surface area of pyramids and cones. And now that we've done prisms and cylinders, the pyramids and cones won't seem quite as difficult because you understand some of the procedures involved. I've got a lot of vocabulary here again. The big thing on a pyramid, first of all, pyramids have one base. They have, as I'm coloring in here, they just have the one base, and they come to one vertex here at the top. So you only need to calculate the area of one base. Now, since we're dealing with the surfaces, we want to calculate the area of the outside surfaces. So the big key I'm circling here on pyramids is the slant height of a regular pyramid is the distance from the vertex, which is this dot at the top, to the midpoint of the edge of a base. And so this dotted line here, that's labeled slant height. And the word slant height, let that be your guide, that it is the slanted height of a pyramid. Now, the altitude or the internal height we consider h. The slant height, you'll see it written as that cursive L. So when we want surface area, that is the value we want. We do not want perpendicular height on surface area of a pyramid. I've given you the net here, and I don't want to spend too much time going over that. We might talk about that more in class, but let's get right to the formulas. I've given you a box here with the formulas, but I'm going to go ahead and write out the formulas again. And this is how you'll see it, I believe, on your reference sheet. The surface area formula for a pyramid is capital B plus 1/2, capital P, and then there's that lowercase l. Now remember, capital letters mean calculated values. B stands for area of the base. Notice there's only one B because there's only one base. P stands for perimeter of that same base that you did the area of, perimeter of the base. And then L, we just said, was slant height. You want the height along the outside of your pyramid. Now, lateral area, we don't want the base. So we want to take away the portion of the formula that calculates the area of the base. So the formula for lateral area will just be the 1/2 PL. Okay, so let's look at an example. We are going to find both lateral and surface area of a regular square pyramid with the base edge length of 14, slant height of 25. So I want you to try to draw a picture of this one. So if you have a visual, it'll be a little easier to work with. So I'm going to go ahead, it says it's a square, but I'm going to angle it a little bit so that I can actually draw my pyramid. So there's my base. I'm going to put a dot up here. And then when I connect, oops, a little bit curved. So you get the idea here. I'm going to try to make the back lines dotted a little bit so it looks a little three-dimensional. Anyways, that's my rough pyramid right there. The base edge is 14, so I'm going to label my 14 there. The slant height is 25. So the height along the side here, and I'm going to add another line here. And I'm going to write L equals 25, okay? So, my surface area formula, step 1, I want you to write the formula. Capital B plus 1/2 PL. So, area of the base. This is a square, regular square pyramid. So the base is a square, side length of 14. So the area of the base is going to be 14 squared. And 14 squared is 196. So, capital B is 196. Okay. 1/2 perimeter of that same base. So 14 plus 14 plus 14 plus 14. So that's 56. Slant height I'm given in the problem as 25. Okay. So now I go through the math. I'm going to do 196 plus 1/2 times 56 times 25. And I get 896. Unit is centimeters, so it's centimeters squared. Okay, that's surface area. I also need lateral area, and my lateral area formula ignores the base. So 1/2 PL. So I have all my values over here. I'm going to change colors here. I want to grab that part of my formula. So 0.5 times 25 times 56. I'm getting here 700. So 700 centimeters squared is my lateral area. Okay, so let's do another one. Moving on to number 2. Find the lateral and surface area of a regular triangular pyramid with a base edge length of 6, slant height of 10. So I'm going to try to draw this triangular pyramid, and it can be a little bit tricky. So I'm going to make a dotted line back here because I know that I'm going to make my pyramid peak right there, and that back part will be hidden. So when I connect, there is my pyramid. Regular triangular pyramid. So that triangle on the bottom, all 3 sides are the same. The base edge length is 6. So we know those 2 are 6 and the back one is 6. The slant height is 10. Okay, so actually I think what I'll do is I'll come in here and add another color. And so that number right there, that slant height is 10. Okay, so I want to do surface area. Surface area is capital B plus 1/2 PL. So I need capital B, I need area of the base. So what I have down here is I really just have this triangle here where I know that all 3 sides are 6. So I know when I calculate the area of a triangle, I have to do 1/2 base times height. Well, I don't know my height. I'm going to have to calculate that height. So you know what that means. I have to do Pythagorean theorem. So when I come through here and add that height, don't forget that that altitude will bisect that bottom segment, which makes each piece 3. So when I go through area, I'm going to do 1/2. The whole base is 6. I'm sorry, let's back up. I can't do that part yet. I'm going to erase that. I have to do Pythagorean theorem in order to get that height. So I have to do a squared plus b squared equals c squared. So I'm going to call my height h. H squared plus 3 squared equals 6 squared. Let's continue. H squared plus 9 is 36. So when I take away 9 from both sides, I get 27. And then when I square root, I get approximately, let's call that 5.2. So that, remember, I'm still working on the area of that triangle. So now I can come over here and I can do my 1/2. The base of my triangle is 6, and now I know my height is about 5.2. So I get 15.6 as the area of that triangle. So now I can come over here. My base, area of my base is 15.6. And then I'm going to do 1/2. Perimeter would be 6 plus 6 plus 6. 18. Luckily I'm given slant height, I'm given 10. So let's run through the math. I've got 15.6 plus 1/2 times 18 times 10, and it looks like I get 105.6. 105.6, and my unit is feet, so feet squared. Okay, that's lateral area. So let's come over here then and do, I'm sorry, that was surface area. I'm going to kind of section this off here. Lateral area, remember, you don't want the base. So the part of the formula you need is 1/2 PL. And so since I can see, I'm going to just circle in a different color. I have my work over there. So I'm going to do 1/2 times 18 times 10, and I am getting 90. So my lateral area is 90 feet squared. Okay, I would like you to do number 3. We're going to call that secret question number 1. So I would pause the video here and I would go ahead and take a look at number 3. Okay, cones are extremely similar to pyramids, and so I want to jump right into the formula here. Surface area of a cone. It's going to be the same as pyramid, the area of the base, but this time the base is a circle. So we're going to plug in our circle formula, pi r squared, and then so that will take care of the bottom part of the cone, and then to get the rest of the cone, we're going to do pi r l. And again, L, I kind of have it written right here, L is slant height. You want the slanted height. Remember, we're doing surface area. We want information along the surfaces. We don't care about the inside of the cone for surface area. So, for lateral area, remember, you don't want the base. So the only part of the formula that takes care of the base is pi r squared. So we're doing pi r l. Okay, let me go through a couple of these with you. Find the lateral area and surface area of the right cone with the radius of 9 centimeters and slant height of 5. So let's draw a picture. Circle with the center. And then let's try to draw a cone. So I've got radius is labeled as 9. And then I want the height, slanted height. So I want the outside. I want that 5 right there. So surface area formula, step 1, I want you to always write the formula. Pi r squared plus pi r l. Cones are very quick. All you need is radius and slant height, and I have that on this one. So I'm going to do pi, my radius is 9, so plug in your numbers. Pi times 9 squared plus pi times 9, slant height is 5. So I'm going to probably keep this in terms of pi. So I have 81 pi, and then 9 and 5 is 45 plus 45 pi. And so that gives me 126. So my surface area is 126 pi centimeters squared. All right, lateral area. I do not want the area of a circle, so I want to do pi r l. And so I can see, since I showed my work above, my lateral area is going to be 45 pi centimeters squared. Next one, find lateral and surface area of the cone. So I usually start with surface area, pi r squared plus pi r l. So I have radius, so I've got pi times 8 squared plus pi times 8. I don't know L. This is my height, but look what I have here on my cone. I have a nice right triangle, and we know that when we have a right triangle where we are given 2 sides and we're missing 1, we can do Pythagorean theorem. So I need to come down here and do a little side calculation. I'm going to do 15 squared plus 8 squared equals L squared. So when I go through the math here, I get 15 squared is 225, 8 squared is 64, and so I am getting 289. That's not a very good 8. 289 is L squared. I know 289 is a perfect square. So my slant height is 17. So I'm going to jot a little 17 over here. Now I can come back, finish out the problem. So I've got 64 pi. 8 times 17 is 136 pi. And so when I add those two together, my surface area is 200 pi inches squared. Lateral area, again, I only want the pi RL. So from above here, I'm doing 17 times 8. I get 136 pi inches squared. Okay. I would like you to wrap up here and do number 6. And we'll call that secret question number 2. And this is where we will stop. We will pick back up in class tomorrow and we'll look at the rest of these questions.